Okay. Yeah. Adi, are we online? Are we live? Okay, great. Okay. Hello, guys. Thank you all for joining Astronautic Institute webinar on next generation rocket propulsion technologies. And today, this webinar has been, as you all know, this webinar has been granted by our guest speaker is Deepak Kurubar sir. So let me give you a brief introduction basically about Deepak sir. Deepak sir has basically done his BTech in from NIT as SIT Bangalore. He has done his masters from NIT Raulkela in cybersecurity. Let me tell you all that he has also worked as a model-based engine performance engineer at Rolls-Royce company. He is currently a rocket propulsion engineer at Spacefields, and he was there at Alton Space as an aerospace engineer as well. Okay. Then now, let me tell you his more achievements. He has worked as an aircraft performance and flight mechanics engineer at HAL, Hindustan Aerospace Limited. He is one of the people who has played a building role in LCA Tejas aircraft. He has right now, he recently filed his another patent which has got 10 plus registered patents in the field of rocketry and drone. He has been hands-on experience and has a successful launch of VayuSat 1A Cube satellite, which is launched by Laksha Space himself. He is also a founder of Laksha Space, and he is also director and mentor of Astronautic Institute. He is also a founder of Mercy Foundation, which is based in Bangalore. So the topic of today is new generation propulsion system, which will be explained by him himself. So I would like to thank Deepak sir for joining today and giving us a really good webinar as well. So I request you all, because see, Deepak sir is always about how you interact with him. Okay, so I will love to give you one tip, that you interact with him, you keep asking questions, and that will give you more knowledge rather than just a particular presentation, right? So okay, so over to you, Deepak sir. Thank you very much.
Okay, so hello. I think I'm audible soon. Yeah,
Sure, sir.
yeah. Okay. So hello everyone and good evening to one and all who have joined this webinar, and we welcome you all for this free session on um, different and advanced new generation propulsion system. What the propulsion system, what new changes has been done, and how the inventions of world in 1950s and 1970s, how it has been impacted, and how it will impact in the future rocketry, and what rocketry is looking into in the newer ages of its propulsion systems. Okay, so that will be the whole agenda of this webinar. But meantime, I would expect candidates to speak up and be interactive with me and also among yourself if possible, so that things will go much interestingly, I feel. Okay, so I think on that note we can start with the webinar, and I hope uh, on the previous sessions also I have conducted some of the webinars wherein which I have started and explained some of the propulsion systems of what you call as for aircrafts. I was explaining over there. Okay, so I hope some of you guys were there as well. Okay, fine. No problem. Today we will look into some of the advanced topics and advanced sessions on rocket science actually. So well, I think most of you guys know that the rocket engines, what ISRO is using, what NASA is using, and what some of the leading space companies like SpaceX, Blue Origin, and even some Indian companies like Skyroot, Agnikul Cosmos, and some other people, what they are using, what rocket technology they are working into, what their launch vehicles have onto their propulsion systems. So, any idea, guys, what it would be like? I hope the basic propulsion, the basic rocket propulsion system should be a little more aware to the candidates. That would be much helpful because see, in coming to rocket propulsion, there will be basically, okay, basically what it is used is solid and Cut mabda, wait. So, coming to the propulsion systems of the rockets, we are having solid and okay, we are having solid and liquid. Okay, so in liquid we are having cryogenic and semi-cryogenic engines. So those are some of the basic foundations of rocketry. In coming to NASA rocketry, liquid and solid. Okay, and also in coming to ISRO's liquid and solid, as well as many other space agencies. But apart from that, there are also some other advanced propulsion system that humanity yet need to be tried. Okay, some of them are, you might have heard of hybrid rocketry. You might be heard of hybrid and cryogenic. Cryogenic is a part of liquid as well. Okay, so whoever has tested it. Okay, so meantime, there is also something called as hybrid. Okay, hybrid rocketry. There is also something called as ionic thrusters or electric thrusters that right now they are trying to work on into. Okay, so these are also in play right now. Okay, in the recent years of 2023 and 2024, but not in deep. Okay, but apart from these, okay, today we will look into some of the advanced categories of propulsion system. I hope my screen is up and clearly visible to everyone. If anybody can confirm it, that would be very well for me. Yeah, with your voice, that would be fine because to switch the tabs
Guys,
again.
Deepak sir is presenting his screen, so that is why I would request you all to speak up. That is why you can just switch on your mic, and you can speak. Right. Okay.
Sir,
Yeah,
the slide is perfectly visible. Perfectly
yeah,
visible.
it is visible, right? Okay, okay. Thank you for the confirmation. Okay. So yeah, we'll be looking into the intro of new generation propulsion system. Okay, which are some of them are developed old. Okay, I mean in the late centuries of 1950s, in the late centuries of 1970s, and yet they are new because they haven't been tried anywhere. Okay, so there is an image I have put over here. It's just to for the purpose of presentation. Anybody recognize this image? What is this? Which engine is this? Anybody? Just out of curiosity, I wanted to have you can speak up, guys, because I
I
need to
think
switch
it
the
might
tab
be
if you are texting. Sorry, anybody? Did anybody say anything?
yes, sir, I think it might be a Raptor engine or the core stage engine of Delta for Heavy.
Kind of. It's a SpaceX engine. It's Merlin 1D. It's Merlin 1D. Okay, it's a SpaceX engine itself. But yeah, good one. Yeah, fine. No problem. Okay, we will move on to the next slides. Okay, fine. So today we'll be looking into some of the topics such as nuclear engines, yeah, and the self-heating propulsion engine, propulsion using detonation, pulse detonation engine, rotating detonation rocket engines, and these are some of the topics, guys, because since the propulsion systems that need to be understood are actually a lot, we'll be looking into some of the propulsion systems that I have been underlined over here. Okay, so these the other few we will be keeping for next sessions. Okay, some of them which I will be introducing to you are electrothermal propulsion system, resistor jet thrusters, because in under electrothermal propulsion system we are having different types actually. Okay, resistor jet thrusters, induction thermal thrusters, radio frequency electrothermal thrusters, microwave thermal thrusters, variable specific impulse magnetoplasma rocket, magnetoplasma dynamic thrusters, and arc jet thrusters. Okay, and recently there has also been introduced a new kind of engine or new kind of propulsion system wherein which organic fuels, such kind of you can call it as a biomethane. Okay, from the cow dung, which was tested by Japan actually. It's called as biometalax engine. Okay, so this is also one of the engine that even we had some of the thoughts previously, but yeah, developed by some other country. But yeah, that's well and good, and these are the topics that we will be looking into, out of which the underlying topics are the one that I will be explaining for today's session. Okay, So make a note of it as well. So if anybody want, you can take a list of these, and you can also study personally. I would like to suggest. So I hope you might have heard some of the propulsion systems previously in your college days or in your school days, in your studies right now. If you are into education, if you are into graduation of aerospace engineering, or somehow in your news or anywhere. So heard of anywhere, guys, nuclear engines or anything like that? Yeah. Any idea on that? Nuclear engines, nuclear propulsion systems, where it is used, why it is used, why it is not widely used right now?
And
Yeah.
basically due to nuclear reactions that occur, just
Yes,
like
go on.
providing so much energy, and sometimes it's uncontrollable. That's why it is not, we are not able to see it in everywhere in engines. But since
Yes.
we want huge amount of energy with short
Yes.
period
Yes.
of time,
Go.
with nice thrust, then we can use nuclear engine because they prefers nuclear reaction.
Sir,
Yes.
good
Yes.
evening,
Yes.
sir.
You know that
Also,
is true.
sir, good evening, sir. Also, nuclear engines
Yeah.
have
Yeah.
high specific impulse. Some examples of nuclear engines are Nova and the Soviet engine.
Yeah. 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 There are also some tests. It basically uses nuclear fuel on its own. Okay. So well, let me shift to that slide. That would be much better. Okay. So the research work of this nuclear engine started in 1973, guys. It's not new. Meantime, I would like to say it. But the thing is, it's not used in space domain or space engines. Okay, it is currently used in submarines as thrusters or as propulsion system. Okay, it is used in many submarines because submarine requires huge amount of power, and if there is any huge amount of explosion or huge amount of what you say detonation that is going to take place, it will be underwater, one thing. And the second thing is, you will get ample amount of water. Okay, I mean gallons and gallons of water under the ocean, so that the nuclear core is always in its, what you say, equilibrium state, or in its thermal equilibrium state, the second thing. And third thing is, it acts like a natural coolant. Okay, because of the heat, the radiation leakage will be reduced underwater. That is the reason why nuclear engines are used. Okay, the nuclear propulsion system, most of the time it is used in underwater, but not in space as of now. But we might get. Okay, we might get. Generally, I would like to ask, I mean, in a nuclear reactor, okay, what kind of energies we will be getting as output, guys? Any guesses, any idea? Suppose let's consider we are having a nuclear reactor. What is the output of a nuclear reactor?
Energy is in form of waves, like very short wavelength waves with high speed, maybe. Sir,
Okay, okay.
Sir, heat energy and light energy.
Yeah, there you go. Heat and light. There is heat and light. Okay, okay, fine. Generally, there are nuclear reactors that's been built by government organization, even including our India. We are having Kaiga nuclear plant, which is under control of Bark, Baba Atomic Research Center, right? And there are also many other nuclear power plants all over the world built by different government organizations, especially. See, one important point of building a nuclear reactor is, yeah, we will be getting heat, but main thing is, out of the heat, what we are going to do, we are going to heat the steam, we are going to convert that into electricity. Okay, basically they are the source of electricity, they are the source of energy to us. Okay, so that is the reason why nuclear power plants has been built, that in first case. Okay, so if nuclear power plants output will be in the form of thermal and electrical, so even in the rocket propulsion also we will be getting these two outputs itself, right? So our engine need to run based on these two energies itself, right? Henceforth we will be having two kind of propulsion systems here. Again, one is nuclear electric propulsion. You can see I marked in a red color over here: nuclear electric propulsion and nuclear thermal propulsion. Okay, so in nuclear electric propulsion, what happens? Okay, we will be getting ample amount of heat from the nuclear reaction, and that heat is used to steam up combustion chamber which will get combusted and it will come out. Okay, that is one phenomena what might happen. And the second thing is nuclear thermal propulsion, wherein which the heat, okay, because of the heat of the nuclear reaction, what will happen, the fluid or the working fluid or the fuel, okay, basically it starts expanding, and that expanding fluid always have some amount of kinetic energy into it, okay, because of the thermal energy, and that can be pumped into a combustion chamber with ample amount of pressure which will act like a thrust system to a propulsion unit. Okay, so that's how the nuclear engines will be working. And in future, if someone is going to test, or in future if someone is going to do a workable engine, we need to do among nuclear electric and nuclear thermal itself. Okay, so this is one of the images I have put up here, which has been tested by NASA. Okay, it was the mission for nuclear and rocket missions. Okay, nuclear rocket missions. It was called as a nuclear rocket mission, and it was started in 1980s. It started at 1973. Okay, so basically we'll be having fission reaction over there, wherein which an nuclear atom will be split into two, and it will be used as a energy. Okay, so can just a basic, like, if anybody have idea, what are the nuclear fuels? Anybody idea, guys? Okay, what are the different nuclear fuels? I hope recently you had a movie also on nuclear system, a
Sir,
nuclear bomb.
uranium and plutonium.
Yeah, uranium and plutonium. So yeah, those are the basic fuels that even rocket engines will also be using, if they are going to come in far ahead. Okay, so basically they will be splitting out with the help of a neutron, which is going to add up, and will be having uncontrolled sometimes if it is not controlled, or else if it is controlled, we'll be having controlled sustained chain reaction. Okay, so that's how the things will be working. Fine. So I hope things are okay till now. Yeah, nuclear engines.
Sir, one doubt.
Yeah.
Sir, what if actually we can apply two concepts together, just like having some heat energy in form of nuclear fission or fusion reaction, and then we can add up with hydrogen fuel cells, so that we have very low cost, and even with interacting with hydrogen fuel cells, it will gain so much kinetic energy that we can use it for propulsion also with low
Yes,
cost.
definitely we can do it.
Is
But
there any
one
problem in that, sir?
yeah. The idea is very good. Combining the concepts of hydrogen and what you say nuclear, and producing lot of amount of kinetic energy, so that you'll get lot of push and thrust. Yeah, that's a well and good concept. But the thing is, see, whenever you are thinking of a concept or a engineering concept, especially in kinds of thermomechanical, thermoelectrical, where thermal properties comes, okay, kinetic energy comes to a working fluid, right? Second thing is kinetic energy also comes to the material science. Okay, suppose let's say if you are building this entire material with the help of, okay, with the help of let's consider lead, or else let's consider you are building it with the help of stainless steel, or else you are building it with the help of aluminum. What would be your material constraints? Okay, you would say, okay sir, I will be building with tungsten carbide, I will be building with the lead, because it will sustain high amount of energy. Yes, well and good, but will it be economically possible? Okay, considering these other two phenomena, okay, most of the R&D work on these engines have been stopped. Okay, basically especially the nuclear engines, because of that's one of the concerns. Okay, sustaining the heat and sustaining that amount of temperature by any amount of material, because even you might have studied the basic amount of the basic nuclear reactor in your normal lower classes. Okay, so there also they will be using working fluid and coolants. Okay, they will be using coolants separately, like a water, okay, that need to be used over there. So if such kind of coolants are not used for nuclear, it will not sustain. And for hydrogen you need different kinds of cooling. And one more thing is, both the working fluid will be having its own ignition temperatures. It will produce the additional temperature and heat over there. Well, it adds more kinetic energy, but the material, I don't think so it will sustain that much amount of heat and kinetic energy.
Yes,
That is
sir.
the
It will be
reason.
more on, yes, sir, more on cost, and the complexity will be more. further.
Yeah, complexity will also.
Thank you, sir.
That's okay. Okay. Yeah. Welcome. Okay. Fine. So any other questions, guys? Any doubts? Okay. Fine then. We can move ahead. Okay. Okay. Coming to the next topic. Okay. I hope my slide is clear to everyone. Okay. This is called a self-heating propulsion system. Okay. uh, we had this concept. Okay, basically I'm talking about theoretical concept. Okay, we had this theoretical concept late in around 1960s and 1970s. Okay, it's not a new concept, it's a old concept itself. Basically it's an engine that is actually getting failed on itself, and it is giving the propulsion system out of it, I mean the thrust out of it. Okay, so basically the rocket is getting consumed on its own, and it is giving thrust, just like the candle. Okay, in candle we are getting the flame, and candle is also reducing its sides, and candle is getting vaporized, and it is giving the flame. Here we are getting the thrust, and the size of the rocket is also getting reduced. Okay, so that is the interesting concept in here. Okay, but you see the practical aspects of this is, okay, whenever the rocket size is getting reduced on its own, okay, the working fluid, basically the gaseous particle or the high energy gas particles, whatever those are coming out of the combustion chamber of the rocket. Especially here you can see one of the practical model that's been tested recently. Okay, here you can see the some of the scale they have measured. Okay, how the length is getting reduced and the thrust is coming out. Okay, whenever the length is getting shrinked, okay, whenever the length of the rocket is getting shrinked, what happens, the working fluid starts to oscillate. We'll be having a lot of combustion instabilities. Okay, the engine will start getting a rupture. Okay, and also it's a benefit, so that it actually gives out, okay, it actually gives out lot of the rocket weight whenever it is flying. Okay, it's a good thing. But the thing is, the aerodynamics, the structure, okay, the stability of the structure, and the fourth point is the combustion instability is very high in this engine. Okay, so that if those things are managed to a very new extent, then that would be good rocket, actually good kind of crazy rocket, I would say. Okay, and there is one more kind of engine here I shown the second image. Okay, wherein which the oxidizer rod, it will be inserted, and it is getting reacted into the what you say, the fuel. Okay, and this oxidizer rod is getting consumed on its own. Okay, it will be inserting completely, and it starts consuming here. Okay, that consuming is because of the combustion. Okay, the combustion because of the heat and thermal radiation that's been released, and based on which we'll be getting the thrust out. So on using this, it has been said that around 5 to 16% of the additional thrust has been increased by using such kind of rocketry. But the thing is, lot of R&D need to be done. Yet this is one of the new generation kind of propulsion system, I would say. Okay, so any questions, guys, in this? Okay, fine then. So we will move into the next concept. Okay, yeah. Okay, so I have mentioned the heading called propulsion using detonation. First of all, um, what is combustion, guys? How does a rocket engine works? Any idea? Yeah. How does a rocket engine works internally? Any idea? If anybody, it's totally okay if you don't know, guys. Please, if you know, please try to open up and speak up.
Just like if we talk about combustions and all, many of the reactions, if takes place, if they are exothermic, then they will provide us energy, and through which we can use it for propulsion. The basic idea is about that.
Yes. So if there is any amount of combustion, and if there is exothermic reaction, and if we are getting the heat coming out, we'll be getting kinetic energy, and we are getting fluids that are coming out at higher amount of velocity, which can be thrown out from a convergent divergent nozzle. Okay,
Yes.
fine. Now we have some idea on combustion. Okay, in rocketry there is a separate subject called as combustion physics and combustion chemistry, guys. Okay, which is one of the heart of propulsion system, I would say. Okay, because it's not been taught in any of the intermediate colleges anywhere in the B or BTech. I don't know if anybody has joined from MSc chemical or chemistry sciences, or from any physical sciences, I don't know. But it is a separate topic under the master thesis in the under engineering. It is called combustion study and combustion instability analysis. Okay, it's a huge amount of topic, especially studying these combustion studies. Okay, so in combustion I would like to give some brief introduction before we get into this propulsion using detonation. Okay, so I think in generally in your day-to-day life, you might have seen combustion generally by firing the woods. Okay, putting some wood onto a fire, or lighting a what you say, the gas stove in your home. Okay, or burning a paper, most probably. That is also a kind of combustion. Basically, wherein which we will be having oxygen and fuel acting together with the amount of heat, and it is releasing the heat that is actually been coming out, okay, in the form of radiation. So that is basically the combustion, guys. Okay, wherein which the particles are being thrown out with a high amount of kinetic energy. That's basically combustion. Okay, but in the combustion there are two kinds of combustion. Okay, one is I mentioned here, deflagration, and one is detonation. Okay, when you are having combustion, okay, basically the gases or the hot exothermic reaction, what is happening, it will come out at two different speeds, guys. Okay, one is lesser than the sound of speed, one greater than the sound of speed. Basically one is at subsonic and one is at supersonic. If we have those pressure waves coming at in the ranges of meters per second, generally in the range of meters per second, then that is called as deflagration, and that is a controllable reaction. Okay, just like your firecrackers example, I would say, or shooting a gun. Okay, and what I would like to say, small bombs that are used to crack up the stones. Okay, in mines and all. Okay, and some of the combustion that is taken place inside internal combustion engines. So in your two-stroke and three-stroke in your bikes and automobile engines, that is a deflagration actually. Okay, but when coming to detonation, it is much more aggressive and it is uncontrolled sometimes. Okay, here we are having in the ranges of meters per second, wherein in detonation we will be having the pressure waves traveling. Okay, suppose let's say this is your actual matter of expansion, you will be having the pressure waves that are traveling here. Okay, just assume that. Okay, which will be in the ranges of kilometers per second, and we will be having huge amount of oblique shock waves in detonation. And in oblique shocks there will be huge amount of temperature changes, huge amount of pressure changes, and okay, but it is a very powerful type of combustion compared to normal combustion what we are seeing in our kitchen and gardens and in our firecrackers or in automobiles. It is much more powerful compared to these two. Okay, yet most of the rocket engines right now uses combustion and deflagration only. We don't have detonation. Yet recently we had some of the progress. I will be explaining you on to that, but have a idea onto it. Okay, have an idea onto it what I just said. So combustion, deflagration, and detonation, this is the difference between all the three. And deflagration and detonation are a part of combustion, and if you want to study more in detail about this, you can go with the combustion physics, combustion chemistry of each of the fuel and materials. Okay, it's a very interesting topic to study, and it directly relates with the combustion instability. Okay, and it's a good amount of study to be done if anyone is interested. Okay, so any questions, guys? Any doubts in this? Yeah, any?
If detonation or deflagration depends upon the nuclear energy, means if we use nuclear energy, then there are more chances of detonation only, not
Yes, yes.
deflagration.
Yes, definitely. If we are using such kind of high energy fuel, see, it depends on, that's what there is called combustion chemistry. Okay, suppose let's say if you are using particular amount of chemical that are very highly combustible, okay, that are very highly combustible, then definitely it would be a detonation actually.
Yes, sir. Okay, sir. Thank you.
Okay, and understand this also. If you want to burn anything, you need certain amount of oxygen percentage to burn it completely. Okay, it also depends on the amount of oxygen the fuel you are having. Okay, suppose let's say you are providing sufficient amount of fuel for a particular fuel, so sufficient amount of oxygen for a particular amount of fuel to burn completely or combust completely, then definitely we might able to achieve these two.
Sir, but if we talk about nuclear reactions and all,
Hmm.
then maybe oxygen is not present in those nuclear reactors
See,
when we react nuclear radioactive elements. Then why we call it as combustion? Because it's not related to oxygen burning, maybe, sir.
there we are not calling it as combustion, we are talking about detonation. Okay, so there the
Okay, sir.
pressure wave is traveling. Okay, the pressure wave is traveling at a much faster rate compared to what we are having in the field of combustion. Okay, so we are having, it's about the pressure wave traveling, understand this. Okay, suppose let's say if you are having a chemical reaction okay, consider this. If you are having a exothermic chemical reaction, okay, I will put it in this way, that would be much better. If you are having a exothermic reaction and you are having the heat waves coming out, and if those heat waves are traveling at supersonic speed, then most of the times it is considered as detonation.
Okay, sir. Understood, sir.
Okay, and in the nuclear reactions, understand this, in nuclear reactions we are having controlled state wherein which we cannot call it as a detonation. Detonation is basically kind of explosion, guys, understand. Okay, there is an abrupt amount of energy released at a particular point of second. Okay,
Okay,
so
sir.
don't
Understood,
confuse,
sir.
yeah, don't confuse with
It's
that.
upon us. Okay, sir.
Yeah, okay, fine. So we'll move some of, we'll study some of the types of propulsion that has been done using this detonation, and how people have overcome this problem of detonation basically. Okay, fine. Okay, here the detonation actually has its history from 1998. Okay, wherein which the early stages of F1 rocket engines has been tested in the early in or in the late of 1950s. Okay, in the late 1998, we had one of the successful F1 rocket engines. Okay, which is ready for its flight. Hmm? But meantime, when F1 rocket engine was being tested, okay, Saturn, that flew Saturn 5 rocket actually. Basically, what happened is its combustion chamber used to have the problem of detonation. Okay, and because of its this detonation, we used to get lot of energy that's been coming out, lot of thermal properties, and lot of shock waves. Basically, a lot of shock waves used to come out, and this shock wave used to disrupt the entire engine's combustion chamber. And I think someone, hello, can you mute anybody who is,
पंकज sir is not listening.
hello guys, please mute it, it will be disturbing others as well. Okay, so NASA had this problem of detonation wherein which shock waves was been developed inside the combustion chamber of F1 rocket engine. Okay, but because of that, what used to happen is the combustion chamber used to peel out like a banana leaf. You can see it here. Okay, this is one of the tests they had done, and they had recovered and kept the combustion chamber of F1 rocket engine over here. Okay, how the engine has been peeled off, and this is the fuel injector of F1 rocket engine. Basically, what used to happen is whenever the fuel used to get injected through this showerhead fuel, this is called showerhead fuel injector basically. Okay, so the ignition used to takes place at a particular point. Okay, suppose let's say if it is taking place at this point, it used to travel down like this. It used to travel down in a circular waves, and we used to get a rotating detonation at a particular point, and that point the engine used to break apart and peel apart something like this. The material were not able to sustain that temperatures. Okay, and to overcome that, what they have done, they have added these baffle plates. Okay, these horizontal structures and these circular structures what you see. Okay, so these are basically the baffle plates. Okay, so these are basically built by NASA on their fuel injectors to reduce the combustion instabilities and these detonations actually. Okay, so rotating detonation I would say. Okay, so the history of this started very long back in late 1950s and 1998, but NASA had this idea, okay, saying that the detonation is actually producing lot more, basically 25% more efficient combustion considering their deflagration engines. They wanted to nail it, and they wanted to bring out an engine that can actually work on completely detonating the fuel and in a controlled way. Okay, so they wanted to do it somehow, but they were unsuccessful until recently. Okay, until recently, and one such development happened in pulse detonation engine. Okay, so this is a noisy engine basically. Okay, wherein which we are having detonation wave coming out in the form of pulses, not a continuous detonation basically. Okay, we are having detonation coming out in the form of pulses. Okay, it's like the sound will be like a Royal Enfield engine uh, with much more loud noises that are coming out, with the much more pressure waves that are coming out. Okay, you can see because of the one of the tests that's been conducted, the entire engine is getting heated up to red hot. Okay, so where in which the fuel and oxidizer has been mixed and it's been detonated just like the internal combustion engine, and the pressure wave has been left in a periodic wave. Basically we used to have some frequency. Okay, we need some frequency, that the controlled frequency that controls this pulsed detonation, and we need to make sure that that frequency should not interact with any of the materials natural frequency, otherwise it will lead to resonance and instability of the structure as well. So that was one of the problem with the pulse detonation engine as well, but it's been successfully developed, but not in current use with rocketry, but they are used in some of the aircraft, smaller aircrafts, where in which they are or UAVs, unmanned aerial vehicles, where in which they have been successfully working, but not much popular in recent generations. But thing is, there is lot been R&D backend that's going on with some of the startups, with some of the scientists in India, where in which they are trying to develop some of the UAVs using pulse detonation engines as well. But the history goes back to 1998 and 1950s. Okay, so this is the brief of pulse detonation engine. So any questions, guys? Any doubts in this? Yeah.
So is it similar to pulse jet engine?
Yes, it is similar to pulse jet engine. Yeah, it is similar to pulse jet engine. But you see, in pulse jet engine, we are having air jet that is coming out. Okay, I don't think so. We are having proper amount of detonation that has been happening. But the thing is, we are having combustion at a see. This pulse is a word that's been used for amount of frequency at which your fuel and oxidizer is getting combusted. Okay, if that combustion is in the form of detonation, it is called pulse detonation. If it is in the form of deflagration and combustion, that is a normal rocket engine with pulse. But if you are adding, okay, stream of jet that is coming out from the unmanned aerial vehicle, or from a jet vehicle, or from a jet engine, then that is a pulse jet engine.
Okay, sir.
Okay, so any questions, guys? Any doubts in this? Okay, okay, fine, then we will move on to the next topic. Okay, so here we had pulse detonation. Okay, I said that it is in the form of frequencies that are coming out. The detonation wave is in the form of frequency that is coming out. Okay, it will be in the form of time intervals. I would consider, suppose per second once, or twice a second, something like that, just like a bullet engine sound. But if you want to have a continuous detonation, that will be a very powerful engine considering this pulse detonation engine. Yeah, so these are some of the concepts of continuous detonation engine. I would like to speak about this as well. Okay, so if anybody is familiar with the fluid mechanics, you should be familiar with the oblique shock waves as well. Oblique shock waves, bow shock, yeah, normal shocks. Okay, so basically what happens is, whenever the detonation happens, I told you things will go supersonic. Okay, whenever the things go supersonic, even in the aircraft dynamics or aircraft aerodynamics, you might have studied that whenever a wave or a aircraft or a object that is going at a supersonic, will be having oblique shock waves. Okay, when we are having a oblique shock wave, there will be huge amount of pressure changes, temperature changes, and high amount of temperature and exothermic reactions that's been happening at that particular point. Okay, so because of those high temperatures that's been achieved in a, okay, oblique shock wave, we can easily detonate, or we can easily ignite the fuel oxidizer mixture at that point of oblique shock wave formation. Okay, because there will be huge amount of exothermic reaction that's been happening, because huge amount of thermodynamic reactions that's been happening. So that's the reason we can easily ignite the fuel oxidizer mixture. And such kind of engines are known as oblique detonation wave engine. Okay, yet this oblique detonation wave engine is just a theoretical study. It says that if a, okay, if a sustainable oblique detonation wave is constantly being produced inside a combustion chamber, okay, then continuously adding the fuel oxidizer mixture will actually detonate continuously, so that you will be getting continuous detonation engine as a propulsion system for any of the rocket. That's what it says. But to create this oblique detonation wave continuously, it's quite challenging, and that's where things are not getting practically right now. But until recently, there has been some study on rotating detonation engine, or rotating detonation wave engine. It can be pronounced as RDWE or RDRE, rotating detonation rocket engine. Okay, wherein which detonation happens in a circular form. Okay, that's a continuous, in a continuous way, in a cycles. Okay, it happens in a cycles. And such kind of engines are developed and tested by two of the space agencies. One is by Japan and one is by NASA, recently in 2022 and 2023. And they are the first one to actually crack the recipe of detonation of continuous, okay, continuous detonation, increasing the thrust of around 20 to 25% of the normal rockets what we are rocket engines what we are actually been using, achieving a higher amount of specific impulse actually. So that's a great powerful rocket engine, I would like to say actually. Okay, so I'll show you some of the images of what okay, this is the rotating detonation engine, how it works. Okay, see, first let's study what the rotating detonation engine actually has. Okay, so here you can see one of the ANSYS fluid simulation of rotating detonation. The blue waves, okay, the before this light blue, dark blue, and this pale blue. Okay, we are having some of the reddish and yellowish wave here. Okay, So this is the place where actually the detonation is happening. Okay, and this is the detonation wave front, basically the pressure wave that is going supersonic. This is the area. Okay, this is the area, this is the area, this is the area, and this is the area. So it goes circularly throughout this annulus. Okay, and in between we will be having some structure like a arrow spike or something like that, or we'll be having some strut body over here. Okay, and we'll be having this detonation wave carried out circularly like this. Okay, ignition will be happening on a circular basis. Okay, and these are the fuel injectors. Okay, so this is how the controlled rotating detonation engine actually been developed, and it's been currently working. They haven't flown into any missions, but yeah, that's how the things are actually. It is called annulus type of combustion chamber. Okay, so I would like to show you some of the engines here in which will be pumping the fuel and oxidizer mixture into these holes, and we'll be having this engine. But this engine makes a lot of noise, to be very frank. Okay, and lot of energy being pumped out, and it's very dangerous to stand anywhere in the nearby vicinity. Okay, so I have seen some of the videos of those engines being tested as well. Okay, so any doubts, guys? Any questions in this? How the rotating detonation engine works, or anything? Okay, fine then. Yeah. So as I said, some of the rotating detonation engines which was successfully tested by Japan and NASA are in the year 2022 and 2023. Okay, so here you can see some of the this is the NASA engine basically with the aerospike in it. Basically not the aerospike, it's a body that need to have in between, so that we'll be having detonation wave. Okay, and it's a very sustainable engine which had a burn time of around 60 to 80 minutes most probably, which was a good burn rate. And here is the Japanese engine. Okay, they have developed and they have also tested it successfully, but they haven't flown into any missions. But yeah, this is one of the recent propulsion system that's been currently under a lot of interest, basically because of its higher amount of thermal efficiency and propulsion efficiency. Okay, because it increases to around 20-25 percentage of existing rocket engine, because that's a huge amount of specific impulse, I would say. Okay, so yeah, and I think that's it from my end for today, as I said for you guys. Okay, so there are also some other engines that will be discussed with you guys in the previous in the next coming webinars. Those are electrothermal propulsion system, resistor-jet, induction thermal, RF electrothermal, microwave thermal thrusters, variable specific impulse magnetoplasma thrusters, magnetoplasma dynamic thrusters, arc jet thrusters, and biomethalox engines. Okay, so but meantime today, because of the time vicinity and other stuff, so this is the uh, end of my session and my talks. So if there is any questions, any doubts from you guys, so please do let me know. Let's have some discussion so that we can conclude the webinar and we can end it. Yeah, any question, guys? Any doubts till now what we had discussed? So this is all about half of, you can consider half of new days propulsion. And there is also one more engine I have put in at the end. Is basically one of the engine from a company called Launcher. Okay, which has tested their engine. The flame looks very good in here. Okay. Yeah. Any questions, guys? Any idea? Any doubts? Yeah. Any new thoughts? Any
No,
new
sir.
ideas?
No doubt, sir.
Okay. Nice. Very good. Anybody? Okay. Fine then. So that's it for my time. So I think we can
Sure, sir.
conclude the
Sure.
meeting.
Well, so it was actually a very insightful session. Actually, I myself learned a lot of new things, and I got a really good opportunity to hear it and grasp some information. So basically, people, thank you for joining. It was really a great session. I request you all, before leaving the session, please do fill up the feedback form, so that we'll be getting the insights that how did you like it, what are your comments, what do you think of yourself, of the webinar. And also, in the coming times, I need you all to connect with us via any of the social media means. We are everywhere on social media. You can just check it anywhere. Respectfully, the particular links are always there in the feedback form. You can have a reference from there as well. Okay, and you can also have the reference from our website, astronautinstitute.com. Okay. Thank you very much for joining the session. It was really a great and interactive audience, a really great session. And in the coming times, we are going to have many such sessions, many such great get-togethers, and we'll be having many other things, many other interactive things, debates, webinars, classes, internships, courses, many other things. Okay. Thank you everyone for joining. Do fill up
I'm
the
so
feedback
sorry
form.
for interrupting. Excuse
Yes.
me.
Yes. Sure.
So could you just please go back to the second slide? I mean, the self-eating propulsion system, so that I can just take a quick snapshot of it.
Shriganda, your voice is very low, ma. Okay, if you can increase your voice, that would be fine for me.
Am I audible now?
Yeah, yeah, now, yeah, yeah.
Yeah. Would you mind sharing the second slide of the PPT? I mean,
Oh, yes, yes,
self-eating propulsion system.
yes. Just
I'm
a
so
minute.
sorry for interrupting at the concluding part, but I would like to
No
take a
problem.
snapshot of it.
No problem. No
No
problem.
worries. No worries.
Do a thing. We will be sharing you the PPT. That can be fine.
Yes, sir.
Yeah,
It will be
that would
perfect.
be great. Yeah,
Or else
thank you so much.
take. Or else, if you want, you can take it whatever if you want to take. I
Okay.
hope my screen is up.
Yeah,
Yes.
it is.
Okay. Just a moment.
Hello,
Yeah, yeah,
Deepak. Hello, Deepak.
yeah.
Hello, Deepak. I'm Balamohan speaking.
Yes, sir.
Deepak, I would like to join with your everyday activities. Like, do you have the website and the Facebook pages? I want your Facebook pages to join for the updation everyday activities.
Sure, sir. Sure. May I know, just a second, sir. I hope, Ma, you have taken the screenshot of what you required, right?
Uh, the
Uh,
self-eating propulsion system, sir. That is the second part.
Uh, for self-heating propulsion part. Okay, you need that. Okay.
Yeah,
Okay,
yeah,
here you go.
yeah. Thank you,
Okay.
sir. Yeah.
Okay.
It would be great if you send this, I mean, if you share the PPT also.
Yeah. Sure. We'll do that. We'll
Yeah,
do that.
thank you. Like I mean, your contact details, I mean, are you there on LinkedIn so that we can contact you there?
Yeah, I'm there on the LinkedIn. I will also share out my mobile number. And sir, you can also reach out to me. I'll share out to my mobile number also here.
Yeah, thank you so much.
Hello, Deepak.
Yeah. Bal Mohan
Yeah,
Ramswamy sir. Yeah.
yes, sir. Sir, your office is in Pune or in Mumbai?
Our office is in Bangalore, sir.
Okay. So kindly share your office address. If it will be possible, I will inform you and I want to meet you for some project work. Okay?
Sure, sir. Sure. I have dropped my contact number, so as you can share your contact number as well, or else call me after the webinar or so. You can connect and we can have a discussion on
Uh,
what the things need to be taken out.
yeah, sure.
Yeah,
So
Som
this
has
is,
also shared the office address here in the chat box.
yeah. Office address, yeah, Deepak office address. Okay, everything I got.
Got it, right? Yeah. Okay.
Okay.
Okay. Anything else, guys? Any? Yeah, Purvansh
Purvanch,
Panchal.
yeah. Purvanch has raised the hand.
Okay, no problem. Okay, yeah, I think we are done. If anyone is having any kind of doubt, so I have sent the WhatsApp chat link, basically our community which is there. You can all join our community. Our website link is also there. Deepak sir's number, he has shared it personally. You can connect with him on LinkedIn as well, and on Instagram as well. Laksha Space or Astronautic Institute, anything is there, so you can connect with anyone, no problem. And in the coming times, of course, we are going to have many such get-togethers, which was great enough. Okay, yeah, I think we are done. Thank you all for your really insightful session, Deepak sir as well, and many other the people, which was an interactive audience. Thank you all, and yes, okay. Balmohan sir, I think I'll share you the link of all our social media platforms to you on the personal as well, and the PPT will be shared to you on our community groups. Okay, so you can join us at community, connect with us on community. Deepak sir, I think he will himself share it on the community so that everyone can access the particular PPT.
Sure, sure.
Okay.
Yeah.
Yeah. Thank you very much. Thank you very much, sir. Thank you very much, everyone. We will see you in the coming times. Thank you. We can all
Yeah.
leave the session.
Thank you, sir.
Thank you,
Thank you.
sir.
Thank you. Yeah. Yeah.
Thank you, sir.
Thank you, sir.